Okay, so this tutorial will show you how to use the Surfer software to produce a digital elevation model, a DEM, and also I'll show you how to undertake a DEM subtraction to produce a map showing scour and fill, and also indicate how to get the volumes of scour and fill from your digital elevation models. So you'd have undertaken a field survey, and you'll have some XYZ data taken from your survey. Hopefully you've processed the survey data to this stage, and you'll need to enter your data into an Excel spreadsheet. So here I have some data taken from the Tinnup Burn, and you should have processed your data so you've got XYZ or Cartesian coordinates. The X data goes in the A column, Y data in the B column, and your Z or your elevation data for each point goes in the C column there. Make sure that there's no header in the column, so you just have data. And this is taken from a single survey for 2003. So you need to separate out your surveys. If you're looking for change in between surveys, then you need to make sure that you've got the data in a separate file so you can compare the two files. So you'll also see here I've got a resurvey taken in 2007 for the same site. So new survey data and XYZ data in the A, B and C columns. Okay, then what you want to do is to open the Surfer software. First thing you need to do is grid the data. So select grid data and then navigate for your first XYZ file. So I'll open the Tinnup Burn 2003 data. And here we can see a box which gives us some options in terms of how we want to interpolate the data. So we're producing a surface through our data points, which is interpolated. It uses a mathematical function to interpolate between the measured data. And we have a series of options here. One of the most commonly used, certainly in geomorphology studies, is to use a triangulation with linear interpolation, also known as TINS. Or alternatively, we could use kriging. Triangulation with linear interpolation has a faster processing time, so we'll use that today. We have some options in terms of the grid we produce over our data, and I'm going to increase the resolution, the spacing of the grid in between the grid nodes to 0.1 of a metre or 10 centimetres. If you're going to undertake a DEM subtraction, you're going to be doing the similar exercise to your other sets of data. You need to make sure that the grid line geometry is the same between the grid files or the DEMs you're going to compare, and in particular we'll write down the X max and min, Y max and min, keep the spacing the same, and also write down the number of lines or number of rows and columns. So I'm going to be doing that now. And we can produce, I'll save that grid file, and it has the suffix .grd. I've saved it on the desktop. So with your next set of data that you want to compare against, so Tinnup Burn 2007, again we're going to change the spacing to 0.1, and this, as long as I make the number of lines the same, we should be okay. So I'm hoping that will work, and that will produce another grid file there. Okay. So then what we need to do, we can produce a DEM of our data. To produce a DEM of the raw data there, the interpolated data, we've got options of producing an image map, a contour map, shaded relief map. Explore these various options with your data. I'm going to produce an image map for the 2003 data now, and we can just see what we get there We can make out the course of the river channel, and what we see is there's areas where the black areas indicate areas where we have no data, no interpolation, but some areas we have probably very little data. We might might want to cut that out at a later date. So that's just an example of a DEM. So one of the next things we might want to do is to undertake a digital elevation model subtraction. Now, to do this, we need to subtract one grid file from the other. So we would select the math function, grid math, and we'd like to select your latter grid file, so the 2007 TINP file. We come up with a grid math box. So in input grid file A is our 2007 data. Select the 2003 grid, and so what I'm going to be doing is subtracting grid file B 2003 from grid file A 2007. So what the software will do is subtract one grid from the other. I'll need to change this so that it says C, the new grid C will equal grid A, which is 2007, minus grid B, the 2003 grid. Give our grid our output grid, or our C grid, a new name. So it's 07 minus 03 TINP. Grid ranges may be incompatible, but sometimes there are issues at this stage, but it has produced a grid. And then we can produce an image map of that grid. It's already selected, and that's the of change. Okay, so what the next thing we might want to do is produce a produce a boundary file to get rid of our unwanted data, get rid of the black zones, and there might be areas where we have very few data points. So what we need to do, I'll delete that, what we need to do is find out exactly where our data points are. So to find out exactly where you've surveyed or produce a map of your data points, select Map, New Post Map, and just select your raw Excel data. So I'll select the TINP file there. So there we have a map of the XY position of the coordinates surveyed in 2003, and we can produce another one for 2007. There's a slightly more extensive survey in 2007, and there's this area here which we didn't survey in 2003, which is unwanted data really, so we might want to cut that out, and I'll show you how to do that in a second or so. What we're really interested in, the only area we can compare against between 2007 and 2003 is the area where we've got the data in 2003. So what I'm going to do is produce a boundary file to go around the 2003 data, and that will allow us to just basically cut and paste everything into that within that boundary. So we're comparing everything just within the area we're interested in. So there's various options. We can reduce our point size here. I just like making those a little bit smaller. Okay, so what I'm going to do is just create a boundary file, click on the post map, and then select Map Digitize, and then simply click in a logical sequence, and make sure you do this sequentially, because if you don't, if you backtrack, you'll have to start this again. So I'm just going around the boundary of the 2003 data. Okay, and then in this file we need to save as, we'll call it TINP 03 boundary. Okay, and that will save. I'm saving everything to the desktop. That will just save as a text file. There's a couple of things you need to do when creating a boundary. Your first point needs to be exactly the same as your last point. So copy the first point, Control-C, copy, and paste it as your last point. So that means we've got an extra point here. The first line of data indicates the number of rows and whether we want to paste inside or outside of our boundary. At the moment it's basically pasting or cutting everything inside the boundary out. So we need to change that to a 0. So we're interested in what's inside the boundary. And because we've added an extra line of data, change that to 32. We've got 32 lines of data. Save it again. And that should give us our boundary. Go back into Surfer. Now click the arrow there. So not interested in these for the moment, to get rid of those. And what we can do now is blank our grid files that we made earlier. So to do that, so this is just pasting everything, the part of the DEM we're interested inside the boundary we've defined. So select grid blank, then select, we'll look at our original grid files now, the one we created for 2003, TINUP 03 XYZ. And that's selected, and then what we want to do is select our boundary file that we've just created using the digitize option. And that will, so we'll save this as TINUP 03 blank, so we know it's the blanked file. And that's just cut everything outside that file. Okay, so we'll do a similar thing for the 2007. Select the blank file again. 1007. Okay, and so that will blank everything outside the 07 file. Right. And if we also do the same to subtraction, the DEM of difference, which is 07 minus 03, okay, so what we can do now is view each one of those. So here is our 03 map. Here's our 07 map. Here's our DEM difference map. Okay. And there's various options you can play around with. At the moment we've got the DEM in grayscale. We can show a colour scale. So this is our Z column. It indicates height, so we've got height in meters here. For the DEM of difference or subtraction, the numbers are slightly different. These are all in meters, but they're indicate areas of change. So up to 5 meters of change, and up to, although there's probably error at the edges of the DEM, it's going down to up to 14 meters of change, which is a little bit unlikely. But certainly in this instance we're expecting up to 5 meters of change in places on this particular river. So we can, what we've basically done there is produce a series of DEMs and a DEM subtraction. Now what we might want to do is find out exactly what volume of change there has been. How do we find out a volumetric change? Well, the thing to do is to click on grid volume and select, because we've undertaken a subtraction, select our 07 minus 03 blanked grid, and we should just be able to keep the options the same as they are in that box. And what this indicates is we have a grid volume computation here. The upper surface being the 07 grid, lower surface being the 03 grid, and it gives us changes in area, and particularly what we're interested in is changes in volume. So areas of and it's useful to actually study to make sure you've got your cut and fill or your erosion and deposition in the same correct. Sometimes a cut area might actually indicate deposition. It depends on how you've actually done your subtraction. But it's indicating large volumes on this river. Again, sometimes there are errors within the DEM, so don't take what it says here as being the true volume. You need to investigate the sources of error within your DEM, which is another tutorial I can give at a later date. But these are volumes in cubic meters of change, cut and fill. So that's how you get your volume. We don't need to say that for the moment. Just to indicate that you can actually load different palettes, if you like. So find out where you've actually loaded Surfer. It's in a folder called Golden Software, Surfer 8 samples, and there's a variety of different palettes here. I like the Rainbow 2 palette, very colourful, and we can highlight areas using colours instead of grayscale in terms of elevation. This is the indicating scour and fill in meters. Okay, so that concludes the tutorial on how to produce basic digital elevation models and how to conduct a digital elevation subtraction.